This is the lesson for Chapter 3, Section 5, Squares and Square Roots. Now the first set of directions asks us to find the square roots. Notice that it's plural, and so that means more than one. And when we're dealing with square roots, we actually do have more than one answer. So let's take a look at the first one. So we've got the square root of 36, or 36 is the one we want to find the square root of. Now we can use this symbol here, and this is called a radical sign. And the radical sign is called that because, well, radical has a root word, a Latin root, which means radish. So radish is pretty close to radical, and a radish is a root that you can eat. And so that's what we're going to end up looking for, are what we call roots. And roots in math are numbers that multiply to make 36. So we need two numbers that are exactly the same that multiply to make 36. And 6 times 6 makes 36. But we also have another set of roots. And so one of the roots, one of the square roots, is called our principal. So our principal square root is 6, because 6 times 6 makes 36. But there is another one. And the other set is if I had negative 6 times negative 6. See, they have to be the same sign. And two negatives make a positive as well. So that's called our negative square root, and that would be negative 6. So the answer for the first one here would be plus or minus 6. So for the next one, we're just looking for the square root of 121. So what two numbers multiply to make that? Well, one would be 11, the other would be negative 11. Because 11 times 11 makes 121, so does negative 11 times a negative 11. So that's why we've got those two answers there of positive 11 and negative 11. Well, here I'm looking for the square root of 1600. And so when I know that 16 is going to end up being, and let's go ahead and break it into these parts. It might make it a little bit easier to see here. 16 times by the square root of 100. And so you see how 16 times 100 makes 1600. Well, the square root of 16 is 4, and the square root of 100 is 10. Well, 10 times 4 makes 40, so that means 40 times 40 makes 1600. So we have two of those answers since we're looking for roots. So positive and negative 40 would be the answer. We also have some tougher ones like 324. Now, I know it's going to be smaller than 40 because 324 is smaller than that number, but it's going to be bigger than 10 because 10 times 10 makes 100. So one thing you can look at is if we have an even number, try even numbers. That means that it's going to be even. And so I know that 20 times 20 makes 400. So I know it's smaller than 20. I know it's bigger than 10, but closer to 20. So I know it's even, so I might try 18 times 18. And sure enough, when you go ahead and multiply those two numbers, you do get 324. So remember that the square root, we're looking for two of them, square roots, they say in this problem. So it's going to be positive and negative 18. Well, the next one says find the cubic root. So cubic means 3 roots. And so roots, remember, are numbers that multiply to make this bigger number, and they all need to be the same. So I need to find 3 numbers that make this. Well, remembering this rule here, if we have an even number, try even numbers. Here we have an odd number, so we're going to try some odd numbers. And also I want to come up with an idea about where it is close to. I know that if I was to do it, I know it wouldn't be 10 times 10 times 10, because those are even numbers, but I know that 3 tens multiply to make 1,000, and I know that this number is smaller than 1,000, so I know the number is smaller than 10, and I know it's odd. So I might try 9 times 9 times 9, but when I go ahead and multiply those out, I get 729, so I know it's smaller than 9, so I might try 7 times 7 times 7, and then I do get 343. So the answer is going to be just 7. Now, the cubic root looks a little bit different. Let's take a look at it. We have that radical sign, which means radish, or the root word is radish, and that is a Latin word, and we're looking for 3 roots. So we put a little 3 in the upper left-hand corner of the radical sign, and so that means the cubic root. If I have no number, that means it's a square root. That means I'm looking for 2. If I have a 3 or a 4 or a 5, that means those are the different types of roots we have. So here we're looking for the cubic roots. So we have the cubic root of 1, and I also can break this into another radical. I can find the cubic root of 64, so I can find them separately. And so the 3 numbers that multiply to make 1 would be 1. The 3 numbers that are all the same that make 64 is not 8, because that's only 2 numbers. It's actually 4. 4 times 4 times 4 If I was to multiply that out, that is 64. So 1/4 is my answer. Now, it's not positive and negative 64 because, again, the cubic root is only going to have one of them, because if I have three numbers and let's say I have all of them positive, it's going to be a positive. If they're all negative, it would end up being a negative, and that's not what I have here. So that's why there's only one root in this case. So here I'm looking for the cubic root of 729 and the cubic root of 1,000. So I saw 1,000 already. That was 10. And 729, we just did that one over here also, so that one's 9. So remember, odd numbers try odd numbers, evens try evens. That is our answer. Well, this one seems quite large, but let's break it apart, kind of like what we did with this one here. So the cubic root of 27, and then let's find the cubic root of 1,000. See, I have 1,000 times 27 makes 27,000. Well, three numbers that make 27 that are all the same would be 3. Three numbers that make 1,000 would be 10. 10 times 10 times 10 makes 1,000. So I multiply those numbers together, and 30 is what I end up with. Well, in these problems, they ask us to simplify. So simplify what is underneath the radical sign first. And so when I do that, I end up with 81. I take the square root, and I get 9. Now notice that we don't have a plus or a minus sign in front. So I'm just going to find the root. Typically, when they ask for square roots, that looks like this. They want the positive and the negative. So they want the plus and the negative when they're doing that. And so if you don't see the plus and the negative, that means that we're just looking for the principal. It means we're looking for the positive square root. So we only have to deal with the principal here, unless they mention that they want both of them. So here we have the square root of 36 is 6 minus the square root of 1. Now this one fools some people sometimes, and 1 times 1 does make 1. So then we subtract, and that's how I get 5. Cubic root of 27 we saw earlier was 3, but here don't try to take the square root of 125. It won't work out so well. So let's go ahead and reduce what's under there. 5 goes into 125 25 times. So again, the way I got that was 5 into 125 goes 25 times. And then I can go ahead and take the square root, which is 5, and then add it to 3 and get that 8. So the next one, I'm going to take the cubic root of 27 and the cubic root of, and I've got 64. Now I kind of made that cubic root look a little bit too big, so I'm going to erase that, because that's a common thing that I see people end up doing, is they make that cubic root symbol a little too large, and it almost looks like 3 times the square root. We don't want to do that. We want to make sure that 3 is in the upper left-hand corner. Over here I have the square root of 1 and the square root of 16. So I'll go ahead and take the cubic root of 27 is 3. Cubic root of 64 is 4. Square root of 1 is 1. Square root of 16 is 4. So I'm adding those numbers together. 4/4 makes 1. Well, we have a word problem here. It says the replica of a square pyramid were built with a base area of 625 square inches. So a square pyramid means that the base is a square. And so I know that the area of this square is equal to 625, so units. And I know that area for a square is just x squared equals 625. So basically what I want to do is I want to take the square root to find out what x is. I want to find out what that length of the side is, and that's what they're asking for. What would the length of each side be? Well, all sides are the same, so it's just finding the square root of this number, the 625. So when I look at that, it's kind of a large number, but it is smaller than 1,000, or bigger than 100. But if I look at the next number bigger, like 20 times 20 is 400, and it's bigger than 20 times 20. So let's take a look at another number, like 30 times 30. If I go ahead and multiply those, that'd be 900. So I know it's in between these two numbers. It's in between 400 and 900. So it's in between, the square root is in between 30 and 20. So I also know it's an odd number. So I'm not going to try like 22 or 24 or 26. And also I see it ends in a 5. So if it ends in a 5, that means that one of the numbers must be 5 that I'm multiplying by. So let's try 25 times 25. And I multiply those, and I do get 625. So that is the number. So when I take the square root, again, I'm just looking for the principal square root here. It is going to be 25. So this is in inches, and let's go ahead and restate our question. We would say the length of each side of the base of the square pyramid is, and then 25 inches. And that would be our answer. Well, those are the types of problems you're going to see on tonight's homework. Good luck.